So actually in the last episode we had discussed it till question number 73. So I'm going to start with question number 74. Okay. So in this question they had given the ratio. Okay. So in generally they had given that n1 by n2 equal to 20 by 1. So we have a chance that n1 may be 40, n2 may be 2, and n1 may be 80, n2 may be 4. Okay, so this ratio should be 20 is to 1. Okay, that doesn't mean n1 is 20 and n2 is 1. So it can be a choice, but it should not be the only one possible condition. So option A is wrong. Okay, so we know that relation V1 by V2 equal to I2 by I1. So V1 equal to 20 V2 and I2 equal to 20 I1. Okay, so secondary voltage is 1 by 20th of the primary. So V2 equal to 1 by 20 of V1. Okay, so this answer is right. And primary current is 20 times greater than the secondary current. No, primary current is 1 by 20th times of the secondary current. So this is wrong. So for every 20 turns on primary, there is one turn on secondary. So if you see, suppose there is 20 turns on primary. Okay, if there is 20 turns on primary, there should be one turn on the secondary. That is right. For every 20 turns. Okay, so this is also right. So option B and D both are right in this. Okay. Question number 75. So the main purpose of using core in a transformer. So generally, uh, we will give a core on this winding will be there, right? So this portion is air. Okay. So air sorry, air has also reluctance, right? So core also has reluctance. But generally air reluctance is greater than the core. Okay. So flux always choose the low reluctance path. Okay, flux always choose the low reluctance path. So if we provide the core, so it will the flux choose this core path, right? So for that we provide the core. So in order to decrease the reluctance of the common magnetic circuit, so answer is D. Okay, okay. Coming to question number 76, the current transformer that is used to measure 100 amp current by 5 uh, ammeter. So here 100 is primary current and 5 ampere is secondary current. So current is stepping down. Okay, so voltage is stepping up. So secondary voltage is greater than the primary voltage. So this is called step up transformer. Generally, this up and downward is based on the voltage. Okay, so this is step up transformer. Okay, the rotating part of a DC motor is known as this we know armature. Here poles is stationary in DC machine. Okay, so rotating part is the armature. The function of the commutator in DC machine is okay. This is already repeated so many times. Okay, in DC machine, generally from AC to DC and DC to AC. Not only AC to DC, AC to DC, and DC to AC. Because here mission is mentioned. Okay, okay. So coming to next question 79. Okay, the DC shunt generator has slightly drooping characteristics, constant voltage characteristics, prices. So they ask for the voltage, right? So if you write the voltage equation in a DC shunt generator, E equal to IA minus RE. So at no load, V equal to E. So during loaded condition, so IA will be increases, right? So V will decreases. So initially it will be E, thereafter it will be decreases. Okay. So slightly drooping characteristics is the right answer. Okay. So the speed of the DC motor, this you know, E is proportional to phi into omega, right? Okay. So you can say speed is directly proportional to back EMF and inversely proportional to flux. So inversely proportional to back EMF, this is wrong. So directly proportional to back EMF and inversely proportional to flux. This is right. Okay. Coming to question number 81, the EMF of the DC generator depends on same equation. E is directly proportional to, I mean, we know the equation, right? E equal to Z and P5 by 60 into A, right? So here, E is proportional to speed. So answer will be B. Okay. Coming to 82nd question, the dummy coil. This I already explained in the initial videos clearly. So dummy coil is provided for the mechanical balance. Okay. Next one, the simple method of increasing the voltage of the DC generator. So general DC generator, if you know E equal to Zn P5 by 60 into A. So if you E is proportional to speed, right? So if you increase the voltage, I mean speed, you can increase the E. Okay. So in order to increase the voltage, we can increase the speed of the rotation. Okay. If you decrease this air gap flux density, I mean if you decrease this flux density, E will reduce. So this is not the right answer. Okay. So answer will be B. Question number 84. The speed of the DC shunt motor is required to be more than the full load speed. Okay, so this is possible by. So what they want to know is the speed should be increased. Okay, I mean more than the full load. The speed should be more than the full load. So in general, you know that E is proportional to phi into omega, right? Okay, generally shunt motor, right? So if you see this is motor. If I assume IARA drop is 0, okay, so E is proportional to V phi omega. So in the shunt in motor, V is constant, right? So omega is inversely proportional to 1 by 5. So if I want to increase the speed, I should reduce the flux. So flux is directly proportional to field current. So if I want to decrease the flux, I want to reduce the field current. So increasing the armature current is wrong. Decreasing armature current wrong. Increasing, not decreasing. So reducing the field current. This is the right answer. Okay. So coming to question number 85. An EMF is induced in the winding of a armature of a DC generator when the armature. So generally we know this is the field and this is the armature. Once the armature is rotating, then this field flux is there. Okay. So it will cut the field flux, then EMF will be induced. This is general DC generator concept, right? So they are asking that armature EMF induced in the windings of an armature of a DC generator when the armature rotates in what? It rotates in the magnetic field, right? So in this magnetic field, it should rotate. So answer will be the B. Okay. The function of the commutator. This is so much, so many times it's given. So AC to DC. Okay. The current flowing in the conductors of a DC motor. I already told that this is AC. Okay. Okay. Coming to question number 88. Okay. So which of the following DC motor the typical field application is mentioned? Okay. So let me explain you some concept. Suppose this is a compound motor. Actually, we implement compound motor with flywheel mechanism. Okay, with flywheel mechanism in printing press. Okay, in printing press. So what is the purpose of this? Generally, what it will do is it stores the magnetic energy. Okay, okay, it stores the magnetic energy. Now come to compound motor. Okay, so not differential compound motor we will use here. We will use cumulative compound here. Okay, I take long shunt cumulative compound. So in cumulative compound, the series field flux and shunt field flux will be added, right? So during no load condition, during no load condition, the only flux is phi sh. When the load is increasing, the flux is phi sh plus phi sc. Let it be phi 1, let it be phi 2. So phi 2 is greater than phi 1. Okay. So if you see this, we know that speed is inversely proportional to 1 by omega. So phi 1 is less, so speed will be more. So phi 2 is high, so speed will be less. So here, if you see that omega 2 is less than omega 1. So what you conclude here, during no load, speed is more. So it give more output. So the flywheel will store that this energy, stores this energy. Okay. So when the during loaded condition, the speed will decrease. So power output also decrease. Okay. So now suppose we generally using the printing press. Okay. During no load condition, this printing press is off. So the compound motor runs at high speed. So flywheel stores that mechanical energy. Okay. Now the load is applied. Okay. Like some bundle of papers are given to print. Okay. So then what will happen? So this flywheel will give the extra energy required for the printing press. Okay. So this is the basic mechanism of the compound motor with the flywheel drive. Okay. So this compound motor also cumulative compound, not differential. Cumulative compound. Okay. So answer will be D. Okay. So coming to 89th question. In a DC shunt motor, if terminal voltage is reduced to off, then torque remains same. Okay. So they had given that terminal voltage is reduced to off. Okay. Torque is same. So we know that torque is proportional to phi into Ia, right? Okay. So phi 1 Ia1 equal to phi 2 Ia2. So terminal voltage is reduced to Vt by 2. So in DC shunt motor, you know that this is the voltage, right? This is the field current. So you know that If equal to Vt by RSH. RSH is the shunt field resistance. So when the voltage is reduced to off, the field current is also reduced to off because both are proportional. So I can write uh, IF1, IA1 equal to IF2, IA2. Okay. So IA2 by IA1 equal to IF1 by IF2. So IF1 by IF1 by 2. So IA2 equal to 2 times of the Ia1. So armature current will be doubled. Okay. So in the out of the four option, armature current is doubled is here only. Okay. Coming to question number 90, the exciting coils. Exciting coils are also called as field coils. Okay, field coils. So these field coils are wounded around what? So around the poles only. Okay. So coming to next question. So which of the following DC motor has least drop in speed between the no load to nominal load? Generally, we know that shunt motor. You know that shunt motor. So generally, you know that shunt motor is we call as constant speed motor. Okay. So there is no least drop in the speed. Okay. So we can say shunt motor. Okay. Next question. 92. If the field of a DC shunt motor is open. Okay. Question number 92. Suppose this is a shunt motor. Okay, this is the voltage. So now this is open. So here IF. So IF becomes 0, right? So field flux will be 0, right? So we know that omega is inversely proportional to 1 by 5. So when the it will be 0, I mean it will be reducing, so speed will be high. So speed will be high. Okay, so answer will be B. Next, coming to question number 93. When the electric train is moving down a hill, okay, so when it is moving down a hill, so speed will be increasing. So E is proportional to speed, and speed is increasing, E will increase. So when this EB is greater than V, okay, when this EB is greater than V, what will happen? Generally, you know that DC motor, here I will write. Generally, we know that, suppose this is a motor, voltage, power will supply to the motor, right? And it is the EB. But if EB is greater than V, then the motor will supply power back to the source. Okay, this is the condition happen. This is called regenerative braking. This is regenerative braking condition. Okay, so now if you see that the motor is supplying power to generator, so it is acting as a generator. Okay, so generally we use in traction DC series motor. So the DC series motor becomes DC series generator. Okay, so coming to next question, 94. Compared to the secondary of a loaded step up. Step up means voltage is greater than the primary, sorry, secondary voltage is greater than the primary voltage, and secondary current is less than the primary current. Okay, so you can say primary, they asked the primary. So primary has low voltage and high current. So answer will be A. Okay. So under the operating conditions of a secondary of a current transformer is always shorted. So this I already explained in the initial video. So answer will be C for the core saturation and high voltage induction. This I already explained. Okay. So coming to 96th question. During short circuit test, the iron loss of a transformer is negligible because, okay. So generally, if you see that iron loss, short circuit test, okay. So in general, short circuit test, what will have? Very low voltage we will apply, right? Very low voltage we will apply. If you know, and transformer equivalent circuit, okay, this RC, right? This RC is the core loss component, right? Core loss component. It is across the voltage. So when we apply the low voltage, so power loss equal to P square by RC. Okay. So when this voltage is very less, the power loss also very less. Okay. So because of this reason, we will ignore the core losses. I mean iron losses. In short circuit test, what we will calculate is copper losses. Okay. So answer will be voltage applied across the high voltage side is small fraction of the rated voltage. Okay. Coming to question number 97. When a 400 Hz transformer is operated at 50 Hz, so generally we know that S is proportional to frequency. Okay. So when S1 by S2 equal to F1 by F2. So S1 we know, we don't know, S1 by S2 equal to, initially it is operating at 400, now it is operating at 50. So 5 edges. So S2 equal to 1 by 8 of S1. So it was reduced. Okay, it was reduced by the 1 by 8th time. So it is the answer. Okay. So the ordinary efficiency of a given transformer is maximum. We know that for the maximum efficiency condition, copper loss equal to iron loss. Okay. So answer will be B. So while conducting the short circuit test on a transformer, which of the following side is short circuited? Let me explain you this. So in the open circuit test, okay, open circuit will be done on high voltage side. Test performed on low voltage side. In short circuit test, okay, short circuit is done on LV side. Test performed on HV side. Okay, these points remember. Okay, because they will ask here. They in this question they asked where we have done the short circuit. So here I already said that short circuit is done on the LV side. Answer will be P. Okay. So question number 100. The commutator of the DC machine act as okay. The output of the DC generator is full wave rectified output. Okay. So answer will be the full wave rectifier. So coming to question number 101. So if the brushes are given for a small amount of forward shift, okay. So let me take the north pole and let me take the south pole, and this is the mission. So here cross, here dot. So the speed, this is the omega. Okay, initially this is the M&A axis. Now what will happen? The brushes are shifted forward. Forward in the sense it is shifted in the direction of the rotation. In the direction of the rotation, it is shifted like this. So this is the flux direction, right? So this is the field flux and this is the armature flux. So what I will do, I will write a phasor. So phi f, okay. So this is the phi armature. So it has two components, right? One is this component, phi 1, and this is the phi 2. So if you observe this, phi 2a and phi 1a. So it is the component of the armature, and this is also component of the armature. So if you observe these two, okay, these two, what it is completely opposite to each other. So it will result to demagnetizing effect. And if you observe these two, like phi f and phi 1a, so the resultant will come like this phi c. So it will be cross magnetizing. Okay, due to phi 2a, demagnetizing effect will come. Due to phi 1a, cross magnetizing effect will come. So answer will be partly demagnetizing and partly cross magnetizing. Okay. Coming to question number 102. A DC series motor is running at a rated speed without any additional resistance. Okay. If an additional resistance is placed in the series, the speed of the motor. Okay. So I will take this is the motor. Okay. So this is the R external, I mean additional resistance. This is voltage. Okay. This is RA plus RSC. Okay. And this is the motor EMF back EB. And this is armature current. So initially R external is 0. Okay. Later R external is added. So here we have to take one condition, whether we have to assume torque as constant, okay, or otherwise we have to assume power output is constant. Okay. So generally we assume this because so there is no torque fluctuations we need. So if there is any torque fluctuations, we will get the vibrations, right? So we will assume torque as constant. So torque is proportional to phi into I. So phi IA1 equal to phi 2 IA2 because torque is proportional to phi into I, which is equal to constant, right? Okay. So if you observe this, okay, if you observe this, phi is also proportional to I because this is the series winding, right? So IA1 square equal to IA2 square. So IA1 equal to IA2. So current is not changing. So current remains constant. Okay. So if I apply KVL here, so V equal to EB plus IA into RA plus RSC plus IA into R external. If I write EB, so EB equal to V minus IA into RA plus RSC minus IA into R external. Okay. So initially R external is 0 because there is no additional resistance. So let it be, the voltage will be EB1. Okay. Now R external is not 0, means it is the second case. So this drop will be there. So let it be EB2. So if you observe clearly, because of this drop, extra drop, the EB2, okay, so will be less than the EB1, right? Because this is the EB1 only. So from EB1, some drop is reducing, right? So EB2 will be less than EB1. We know that E is proportional to phi into omega. So E is proportional. Phi is directly proportional to IA because this is series motor. So here IA is constant because we assume that torque is constant. So E is proportional to omega. So E2 by E1 equal to W2 by W1. E2 by E1. So otherwise, omega 2 by equal to omega 1 into E2 by E1. This term will be less than 1 because E2 is less than E1, right? So I can say omega 2 is less than omega 1. So speed is going to reduce. Okay. So it will not going to increase. So answer will be B. Okay. Next, coming to next question. So question number 103. So plugging of the DC motors is normally executed by. So I already said in plugging what we will do. The armature terminal will be reversed. Okay. This is the plugging case. Okay. The armature terminal will be reversed. So reversing the armature polarity. Okay. Coming to question number 104, the direction of the rotation of the DC shunt motor. So this I already explained. So if you want to change the direction of the rotation of the DC shunt motor, we have to change both field and armature terminals. Okay.